Well, what do you say we get started? Sound good? Okay. All right. Welcome to the webinar. My name is Ken Gracie. I'm your host. I'm joined by two of my colleagues, Kate Hay, who is the co-host and Parallax STEM educator, and serving as flight controller and problem resolver is Stephanie Lindsay, who has too many jobs to list to give a real formal title. So Kate will help keep us on track. Stephanie will make sure everything works technically and that questions are answered along the way. This is the second of 5 webinars being run by Parallax this fall, and you can register for them here on our events page. Next week we're talking about block leave for hobbyists, and then college, and then we're moving into the badge, and then we're taking off on trade show events. So it's going to be a busy fall for the team. So this is our second webinar so far. Earlier Tuesday was a middle school, and then we're in high school. Next week we're talking to college instructors. So I'll set the stage. First, Parallax serves education, as you know, and that's pretty much what we do exclusively. But we're not in the classroom, and we're really close to all the things that you all are working with, the robots, electronics, software, and the hardware, and we spend almost all of our time behind the scenes getting all these tools to work right, as you know, because you call us when they don't work, and then you're excited when they do work. And we've trained a lot of educators, and we periodically get time in class. Several of us have that experience and have credentials too. But the webinars are a great chance to hear from our teachers and to hear them talk and learn back from them. So we're super excited to have their attention today. So I'll introduce them in a minute too. First off, about the Zoom tool you're using. You might be looking at a million different windows like I am. Don't be concerned, you can move them around the way you want. But the most important thing is, how do you interact with us on a webinar? So on the bottom of likely the video display area where you see all of our pictures, you'll see a black control bar, and there's a Q&A button. You can press on that and then submit questions. And I see that Carol's already tested it. And then you can try the chat, which may be under the more on the right side, at least it is on mine. And you can also raise your hand on the attendee list, and then you can talk. So you can ask questions, type questions, however you want to interact. We welcome you to do that. And thank you for your time too. We know it's dinner time on the East Coast and it's almost soccer time on the West Coast. So did we miss anything, Kate?
I think you covered it very well.
Okay. So these are our panelists today. These are 3 very special educators from the West Coast area. So I will introduce them very briefly, then they can tell us for a few minutes about what they do in their program, maybe what classes they teach, what they're using, what hardware, or where their money comes from, whatever is of interest. So the first is John Wurst, who's a science, engineering, mechatronics teacher at Forest Grove High School in the Silicon Forest area of Portland, Oregon. So John, thanks.
Yeah, thanks for having me.
Tell us a little bit about what you're doing.
So I'm really not that experienced in robotics and electronics, but I had a robotics club that I inherited as a new teacher, you know, the first robotics type challenge thing. Failed horribly out of the first year, and I got this postcard in my mailbox a few months later saying, you know, come learn block leap prop in Seattle, and it had like code that looked similar to like what I guess my club was supposed to do. So I went to the conference and was successful like right away. You know, you build a little robot, you learn how to code it, like, and so I went to my administrator and said, hey, we have this Measure 98 money in Oregon. Measure 98's like CTE, college career education, college or career and technical education. And like it's meant to reduce dropout rate and improve on trackness, I think, for students. So we had some of this money for CTE. I said, hey, can I get an engineering class and we'll run these little robots in there? And it worked out. You know, like the curriculum online is great. Like as somebody who doesn't know, like I can go and learn how to do something, then teach my kids how to learn it using the tutorials. And then we set up some sort of group challenge together, come up with some idea. And it was just a great year. And so we heard about this program at our local community college that trains high-tech technicians, and that there was this revitalization grant in Oregon where you could get like $450,000 to start a new CTE pathway. So again, just propose the idea like, hey, let's join up with this community college. Let's run the robots for the first year. And then the second year, start the community college program in high school, you know, get them hooked, and then you do digital logic type stuff with the kids. And it worked. We got the grants. And so we advertised the pathway to everybody. I mean, we made videos and went to like the middle school. We pushed into like all different science classes because kids are required to take like 3 science classes for freshman, sophomore, and junior year. And just we took the robots in, and we had accounts set up, and we showed them like 3 blocks, and then we set up some mazes on the ground, and kids in like 45 minutes were like running robots around the class, and they've never done it before. So we got 360 kids to sign up for this pathway, hired another teacher. And so we're just kind of like figuring out what to do now. So we started the year in a very similar way. Like we started with 2 class sets of already built robots. We like showed them what it's supposed to look like, how it's supposed to work. They ran some mazes, and then we had them start building it. And from my experience with a class of like intro to engineering students who signed up for an engineering class, building them can be kind of a challenge, you know, like kids following directions or not following directions, like not reading, just looking at pictures. And so we gave them this build document where they have to like draw a diagram and label it and write a sentence for each one. And it slowed it down to where it took them like 3 days to build the thing, and they turned out great. So now we're just kind of like figuring out how do we do robotics with like kids who their goal is to graduate from community college. And so yeah, it's kind of like this challenging place to live in. Like if a kid has attendance issues and they show up half the time, how can we get them doing the same projects that everybody else is doing? So that's kind of the world I live in right now.
And you're serving 2 types of students, those who want vocational trade jobs and those who are going to college.
Yeah.
Too. You attract them both.
Yeah.
Excellent.
Oh, yeah, that's my world.
Yeah, so there's a big semiconductor plant near you.
Yeah,
and that's the employment base.
Yeah, like Intel, D1X, or they have like a bunch of fabs, D1D, like 15,000 workers. And there's a bunch of other semiconductor companies that all support them. And then there's other fabs around, like, and the starting pay is double our median household income in our school district. So it's just 30 minutes away. And so we pitch that to kids, say, hey, you could make $60,000 a year with a 2-year degree. And it really gets them in the door because they're looking for a plan, and it's a very doable plan.
It's awesome.
Yeah.
Great. Thanks. And so next we'll introduce Faith Kaplan. She's the Engineering Academy lead teacher at Cordova High School. And prior to teaching, Faith worked for Hewlett Packard and did materials engineering for, am I correct, 20 years?
No, 5 years.
5 years. Okay. It's like, yeah. You can't be that old. So you have a lot of experience in industry too.
Yeah. So I worked at, in Corvallis in Oregon. Actually, I went to Oregon State. And then I moved to California to teach or to work at Hewlett Packard in Roseville here. And then my husband is a teacher, and it looked really fun. And I spent all this time with kids with volunteering. So then I did the credential program and started teaching 10 years ago. And I first started teaching math, and then I moved into engineering. And the teacher that had been teaching it for 9 years, and she was very into following like the plan that was laid out with the curriculum. And I'm more of like throwing things out and starting over. I don't know. And not that I enjoy that, but I would do something and the kids are not into it. We had incredible, like we had 20 kids in each grade level in the classes. It was very math heavy without a lot of like open-ended problems for them. So I'm in the process of rewriting my curriculum, and I have one in the sequence. One is specifically all focused on robotics and electronics, though each class has a little bit of it. So like my freshmen do soldering and LEDs, and then my sophomores are doing the robotics, and then they're doing the digital logic the second semester. And then my juniors are doing like a survey of different design and engineering professions. So I'll probably do a little of electronics. And then senior year, they can kind of dabble in whatever they were into because I have 3D printers, laser cutters, and they can use those parts to make cooler robots. But as far as hardware that I have, I have a bunch of, I adopted years and years of Vex robotics. I adopted years and years of Bobots, like old, like your first version of Bobots probably. And I'm having one of my students take all of them apart and see like what common materials there are and rebuilding them. And then I have Arduino, like 2 or 3 different versions of Arduino. So it's really, for me, I have all the stuff, and I have a grant from Prop 98 also. And in California, we structure it in academies. So I get paid, like my academy gets around $70K a year through that grant. And we have all these different things we need to do to be an academy. But that is able to fund like pretty much anything my kids ever want to do. So I just say, if you see something, just tell me and we can see if we can do it.
And then you do the dreaded, please give me your material list, and then you wait to see what they do, right?
Right. Well, I need to get better at having them have a really good plan, because I have bought things that really did not need to be bought and didn't get used. But we did do our first year of a solar boat race sponsored by electrical company SMUD in our area. So we did that for the first time last year. So excellent. I'm still learning. I've been doing this 4 years, but I feel that this is the first year where I feel like I'm above water and like I'm got completely full classes and our program's good. I'm just still like defining exactly what projects I have and writing everything down so that I don't have to redo it every year.
Yeah. Well, good job. Be easy on yourself. We've been to your classroom, and there's a lot going on. I was really impressed with all the tools and the projects.
Oh, thanks.
Yeah, we don't see that very often, but sounds great. And you have a lot of local partnerships too. It should be pointed out, and partnerships with companies, and you've kept yourself really well connected, which is helpful.
Thank you.
And next we have Scott Cermak, and Scott is similar to another teacher we had on Tuesday's webinar. He teaches English, creative writing, and robotics at Choices Charter School in Sacramento. And you started out as a music teacher 3 decades ago, right?
Yeah.
And
so
tell us all about this.
Yeah, I actually started off as a musician. I'm kind of the oddball in the group, I guess. I was not I didn't do very well in school. Didn't find my way except for music. I always loved music from elementary school on. And when I guess I got barely through high school, and then in college did not do well at all. Ended up going off to music school and did that as a career for a while. And kind of the pat answer I always tell people is I did everything in the music business except for make any money at it. So by the time I got married and had a kid, I had to decide what I was going to do, and realized that when I was not on tour, I was always back teaching music lessons. And so I thought, well, maybe my big boy job would be to become a teacher. So started exploring that and went back and repaired all my college mistakes and did really well. And actually, for the first time, fell in love with education, which was great. But along the way, I've always been kind of into, I used to call it tinkering, I guess now we call it makers, but I've always been into taking stuff apart and building stuff and how things work. And so through school, I ended up teaching elementary schools where I started about 20 years ago. And that was great. And one of the first projects I did way back then, which I'd probably get in trouble for now, was they used to just throw all these old computers away, as it was, I don't know, every 3 years or so. Well, I started collecting them, and I had actually a 2nd grade class that I would have them sound similar to what some of the other panelists were talking about. I had the kids literally just taking them apart and hooking up 9-volt batteries to disk drives and making them open and close. And it was the most fantastic learning. It was like authentic, real hands-on learning. So then kind of fast forward through many years elementary school, I got kind of burned out and took a break and found myself here at Choices Charter School. And we're a public charter school, which means we get money sort of like a traditional school does, but we get to kind of choose what we do with it. And one of the programs that was missing here, we already had I'd love to teach music, but we already have those jobs covered. But we didn't have anything sort of in the robotics area. And I think it was John Agostinelli we were talking about before the podcast started. He was the one at our career fair who had mentioned Parallax and got me to sign up and came up and took a class with Matt. And I went, this is it. This is perfect. It's great. You guys have done all the legwork. And so last year we brought it to our school, had a great turnout of kids, And this year I've added the scribbler to it. And while we have kind of smaller class sizes, it's just been the greatest thing for these kids to get some hands-on experience with building. And one of the things I wanted to throw out there in case there were some people watching, our school as a charter school is a little bit unique in that I only see my kids once a week. So like say for my robotics class, it's a 2-hour class, but I only see them 1 day a week. So part of my challenge is trying to fit all that activity throughout the semester with just having that contact because there is so much hands-on. But we're working through it, and I think, you know, I mentioned before, it's kind of fake it till you make it, and trying to figure out each year and build on it. But like I said, just having the kids have an authentic hands-on experience has been wonderful.
You know, every teacher we talk to is learning as they go with this, and none of you are alone. It's interesting because they all point that out, but whatever you want to call it, fake it till you make it. It's all new stuff. And so you can't really know about it a lot of times until you're doing it. I mean,
true.
There are parts that come out every day at Parallax that we discover, and then they get pushed in your direction.
Well, we love it. I mean, I like I said, I love all the groundwork you guys have done. It makes it so accessible and easy. Because I mean, being a tinker, I kind of understand basic building, but the robotics part, I really had no experience in. And the training provided just a great a springboard to bring it right into the classroom.
Great, thanks. So here's our first question for the three of you. We have two of them. And Kate and I crafted this because it's something we discussed when we're sitting, we share an office, and we were asking ourselves, how do we create these deeper learning opportunities for students and get them past the fixed mindset that some of us have? And so they really get engaged and they enjoy what they're doing, and they're really, really learning and not just making their way through the class and getting grades.
Yeah.
So how do we do that? Who wants to answer that tough question? You all get a chance at it. Faith, you want to go for it?
Sure. And I think like with the fixed versus growth mindset that we kind of talked about before, I was thinking about that, and I have a lot, well, I don't have a lot of girls, and I feel like girls are some of the hardest ones on themselves as far as if they don't get it right away, they're like, they only take my class for 1 year, and then but then they really miss the hands-on part of everything. So one thing that after noticing that, I've started at the beginning of a unit, I have them all take a Google form, and I have them tell me like personal things about like their feelings, you know, like, or how much experience do you have with this programming? Does it worry you, and all that kind of thing. So then they can kind of see like, oh, I guess only 3 people in here really know what they're doing or feel comfortable. So, because they always tell me everybody else knows everything. And it's like, no, they're all learning it at the same time. I mean, a few kids like could teach the class. Like they've been doing STEM for their entire life. And I think they're vocal and they say words that no one knows what they are, or programs that no one's heard of. I think kind of getting them all on the playing field, like we're all learning this together, you know, and then I think it really helps to get the products in their hands without doing a lot of instruction first. Because if you do too much upfront, they lose interest.
Yeah.
And then the competitions are always really awesome. Like if every single project you did have like some element of competition, you would hook most of them. So.
Faith, do you work in teams? Do you have groups of the students on one robot, or how do you configure that? Because that sometimes helps too, or hurts.
I do 4-person teams, and I change teams every unit. Though I'm kind of considering changing that because I feel like there's something to be said about working out issues with your team. Mm-hmm. And kind of, because I had one team in particular in my freshman class that somebody was having trouble, and I wanted to talk it through, but it was kind of at the end of the unit, so you wouldn't have an opportunity to test all the learning about teamwork. Yeah. So I feel like, but then also at the end of a unit, some kids are just ready to move on. So I want to balance those two things. Yeah.
So you let them know they're not alone, right? And mm-hmm. help them be comfortable with the topic. Mm-hmm. And then when you start, you try to minimize the instruction, the traditional kind of instruction, and so they can get working. Mm-hmm. And then once they're doing things, then you have competition. Mm-hmm. And this engages them.
Yeah.
Wow, perfect. Okay. Scott?
Yeah, I'm learning as much listening to this too. I'm inspired by the stuff you guys are doing. I so want to be able to do that competition portion of it, but we're just quite not there yet. And I look forward to that. I have some other colleagues up here that do it too. But I think, back to sort of basics, what we were talking about earlier was, I think this critical thinking aspect of being able to follow directions and, go step by step and slow down. One of the things I see kind of being the old fart around here is that these kids are, and I guess I find myself falling into it too, are doing so much the listicles and the skimming and the scanning and not reading for content. And, part of that's near and dear to my heart as an English teacher, but I love just those Parallax lessons with the activity bot that we're doing. If you don't go step by step, like just today we were in the build and they were just putting stuff together and I kind of just oversee, kind of turn them loose, and they were not putting the encoders on, the servos before they got the 4 bolts in. And so I'd come around, they're like, well, how do I get this on here? And I said, remember when I said, follow the steps? Missed one. And then, but that process is so great because it's authentic, it's real. They're, they have to problem solve. And isn't that what we have to do in real life away from school? And so I think that sometimes gets overlooked. They want to see robots flying around the room like we talked earlier and all these crazy things, but really that problem solving ability, or, understanding when you turn that light switch on at the wall, what happens before it gets to the light turning on. I think those are super valuable things.
Well, I have a parallel in Parallax that always troubles me personally about education, which is the tools keep getting higher and higher level.
Yeah.
Like Blockley's a really good example. You can set a servo pulse in going and it's maintained for you. Okay. And so now you can drive motors around, but it seems so important to step back and then show them what a real servo pulse looks like and what the time base is, because timing is everything in programming.
Sure.
And there's so much desire to fast forward into the cool stuff, but then they miss so much too. And so I wonder if that's, if any of you face that when you're teaching, like, do you really try to get them back to, as difficult as it is, the basics, the fundamentals, and the understandings, or do you balance it?
I guess it's kind of a balance.
Interest.
Yeah, sort of a case by case. And as a teacher, I kind of look for those golden opportunities, just like you said, when you see a kid struggling with a certain thing or a certain situation, to break it down and have them, kind of regurgitate back to you what's going on, have them pause, because I just find, again, they're trying to go through everything so fast and get to that end product, and they're missing all of the things along the way, which I think that's our job, is to be able to kind of governor that back and slow them down a bit.
Very good.
Yep. Okay. So John, how about you?
So growth mindset's like a school-wide initiative that we've been working on for a few years. And for us, well, I guess, especially for me with the equipment, sometimes I'll get a kid who, I'll put like a template for a program up. Like we're doing this swirl maze right now. It looks like the PCC logo, and you got to use like drive speed and pauses, in different, like segments, sections. And I had some like kids who like didn't want to start because they're like, I don't know what numbers to put in. And it's like, well, they're free. You can just test them out, and if it goes this way, this is how you change it. If it goes that way, this is how you change it. And then like I messed up, right? Because I didn't realize it's going to take so many segments of code to get there. And so we had to like build the speaker circuit, and it's like, okay, you need to put in a different note so you can tell where what section of code the robot's on, because we're going to make them connect it back to a diagram that they draw and then comment in their code, go over. And so just modeling for them, like, I mess up, you mess up, let's mess up together. Like that's what testing is in this field, right? You just see what doesn't work. And so for us, that's it. It's like, be careful with the equipment, but play around, And so I think giving them challenges that they can like work on, so it's difficult enough so that there's like, more than one way to do it, and it takes them a while and it gets them thinking, but also enough tools so that they're able to work through the problem, you know? And so for us, that beep was a huge one, you know, like let's put a beep in there because why not? I mean, it's perfect.
That's awesome. Absolutely love the idea what you just said about them finding those thresholds. I mean, I think that's so great for them to, we were at actually Kate and I were at a CCIS conference last year. One of the professors there said, she does an interesting thing. She doesn't let her students get an A in the class until they get an F on one assignment. And it was kind of that idea of to push yourself, or push the idea as far as you can until you can't do it anymore, which, you know, you're learning your own threshold. And that, I mean, that goes with the student as well as the equipment and the lesson itself. So hats off, that's awesome.
Yeah.
You're challenging them for sure then. All of you are, it sounds like. One tip I have for you, since I got you all here, which is when your students are building these projects like you're talking about, John, and they have a lot of things going on, like this is a light sensor and a line follower, and then there's a speaker, and there's also an RGB LED on top. This is a colored line following robot. And this is true, what I'm going to tell you is true of everybody that designs projects with embedded processors. Build things in little steps and make them work in small pieces. And then you put those together, you test and code as you go with your mind on the completed program, so you know how to structure things. But students so often, I think they can get turned off and then they never get to the real challenge-based learning because they get turned off. I've seen them throw things together and just try, just kind of brute force it, but they really, really impress upon them attention to detail, quality workmanship, commenting their code, and just taking their time.
Yeah.
And you could spend a whole semester with LEDs and push buttons too. And that's actually good for them.
I try to do LEDs for quite a long time, but then I do one sensor at a time. And I show them like the difference between like analog sensor, you know, readings and digital readings. And then, because again, when they try to do too much, like you're saying, and they try to just throw everything and copy code from the internet, it doesn't work. And then they just say, I can't code, I'm done. But it's like, really, do you understand a single line of this code? Because then it's not yours. So, yeah, just learning it step by step is really important.
Yeah. And so we threw that swirl maze at kids before we even taught, like we didn't go through any programming tutorial at all. We're just like, get the stuff from the left-hand menu and put it together on the right and go. And so we had all these, you know, some kids were stressed, you know, but once I think you get over that hurdle, it's like, it's okay if you don't do it right, you know.
Give them a Fibonacci spiral.
Yeah.
So one of the things we're interested in knowing too, and you've talked a little bit about this before we started, does your school have a STEM mission? And you know, how do you know if you're meeting those goals, or does it matter? Do you create your own, and your programs give you that flexibility? So I guess we're asking how much of it is directive and how much of it is teacher driven, and then how do you measure it? And those are probably three big questions, but I'd like to have your thoughts on that.
I guess that's a big one. So I'll speak for our school being, again, a charter school. We sort of write our own charter, and it's built in. And we don't have necessarily a STEM mission, but we have what we call graduation outcomes. And they're real kind of big ideas like critical thinking, creativity, collaboration, and what's the other one I'm missing? Communication. And those all fit so well with robotics, especially talking about, you know, having kids work in teams and work through problems and all that stuff. The piece that you bring up that we really need to probably work towards, though, is how we measure it. So I'm interested to hear if any of the other panelists have ideas on that. But we're kind of building it as we go. And it's kind of nice that we have the flexibility to do that. But at the same time, it'd be nice to rein it in some too. So I'm interested to hear what you guys have as far as measuring, you know, hitting your goals or your success rates.
So at my, oh wait, sorry. Were you going to summarize?
Want to hear from you.
Okay, sorry. For our school, our English and math scores are incredibly low right now. So that's the mission of the school, really. Though our motto, I guess, or vision statement is career and college readiness for all. And so we have a lot of career technical pathways. And so I think we're focused on getting kids a job, either with a career or college and then a job. And so for my academy, I feel like I'm able to kind of create my own mission, which is nice. My mission for our academy is just for kids to be able to feel comfortable with opening up things and knowing what's inside and how it functions and potentially fixing things. And then also preparing them from like engineering, higher degrees too. But with our math proficiency so low, I don't have a math prerequisite. So I've had to take a lot of the higher level math out or scaffold it and have different levels for different students, which is challenging. But I just try to reinforce the things that I want them, I think every student should have. Like every student should be able to read a ruler in fractions and decimals. And every student should be able to use calipers and understand, every student should be able to estimate and convert between units and convert, so read a resistor, but that's more, I don't know if that ever, but if you're going into electronics, But for measuring, one of the things is how many kids do you have?
Yeah.
And then how many kids stay in your program if you've got multiple classes? And I actually track my kids all 4 years. And I track them when they leave, and if they happen to not take my class the next year, then I kind of ping them and I say, so what's going on? It might have been they just needed their VAPA and they didn't have room in their schedule or whatever. So I think that's a really good metric, how many kids actually keep going. You could say how many kids are articulating and getting college credit, how many kids get a job afterward in the field. So
yeah, and it's hard to measure because you're giving them basic technical skills that they have to have these days. And there's so many ways to do this, and you're using tools and processes that they should enjoy, which keeps them engaged. So sometimes I think we also look too deep into these topics, like with programming. I love this term, programmatic thinking or computational thinking, partially because I'm not a programmer really, but I understand programming, and in our office, which is mostly technical people, we have only really a handful of coders, but everybody understands what they do and how it works and the tools they use. And I see that being a real value of education, is the exposure to it. Sometimes more than really learning about all the variable types and the sizes and signed math and this kind of thing. This is good if you're going to really go into programming, but everybody should understand this kind of thinking. So for me, that's a refreshing approach you have. That's just somewhat, in some ways, kind of basic career college readiness. You don't have a lot of math prerequisites, and you're teaching them how to measure, draw, to code, to build something, and use their hands. Because they've really lost the opportunity through our phones. I don't want to sound like a cranky old curmudgeon, but it's true, because I also work in a school. So,
well, I got to tell you, not to jump on, but one of the biggest things, and it's so rudimentary, is when I started handing out screwdrivers and they're literally putting bolts and nuts together. This was a whole new, I had to teach some kids how to hold a screwdriver, which for me was so foreign. But the old curmudgeon thing, you're right, these kids have done everything so virtually, and literally just that very simple mechanical hands-on thing, I think, is so valuable.
Yeah, we had to teach kids how to put in batteries.
Yeah.
Important lesson.
And when you look in the news, the other job that I have is a real estate company. We do flips and have contractors and stuff, and we're watching contractors and hands-on in the trades just completely disappear. And I think I just read something like 85% of the country is having problems finding contractors and people that can actually do skilled labor. It's disappearing. So if we can get these kids at least somewhat interested in it, I think that's a huge game changer for the future.
Well, and the economics show that too, with 80% of the high schoolers rushing to college and not really knowing why. A lot of them are foregoing valued trades.
Yes.
John, I'll switch over to you.
Very similar. We don't have a STEM mission per se, but our vision is preparing all students for college career and world-class citizenship. So we're really hitting the career part this year, especially with there's this huge renewed focus on CTE pathways, they call it in Oregon, where if a kid does 3 credits, you get so many points towards a grant. And then if they pass an industry certification, you get like double points. And underrepresented population, that also counts as double points. But we brought up in a meeting, we said, hey, we measure our success based on ACT scores. That's college. How about we count kids who complete a CTE pathway as being like career ready? If really like our pathways are rigorous, if they include like community college, dual credit, some sort of like applied program, then they really are ready for the next step in their career. And so we're looking at it like that's one of our, I guess you call it a STEM mission, because I think of STEM, like our CTE pathways, like they're all somehow related to science, technology, engineering, or math, whether it's culinary or we have a great construction program. So that's really where we're at, is we want to get more kids going through pathways, just because it is like fun and hands-on and engaging, and we can get money for them to do that if we can get them to go through all three years. So.
Wow. Kate, is that about what you expected to hear?
Yeah, I knew the question would vary, but it's very interesting because all we hear is STEM, 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 and what's your mission? But to hear how it actually is managed in the high schools is very interesting. And how do you? I mean, when you're looking at the tools you use in the classroom, do you have to? Do you go through? It sounds like definitely Faith has a lot of different tools that you use. You have Vex and you have Parallax and you have Arduinos. How do you measure the effectiveness of the tools you use?
Which ones?
Yeah,
like which ones are working and which ones don't work, I guess?
Yeah.
Well, for me, I'm hoping that they can be lifelong learners and electronics people and kind of go into a maker's fair as an adult or work at Parallax. I don't know, you know what I mean?
Yeah.
Just kind of tinker and make crazy things. So I want them to have opportunities to buy. So like I'm really into cheap things that they can buy at home, and I teach them how to buy it. Like for Arduinos, you can buy like a $4 Arduino that works, that you could, I was saying, when you're an adult, I want you to be able to like put your Christmas lights to music or something. Like you have a crazy idea. Oh, I want to set up a watering system, an automatic watering system when I'm an adult, or so they can kind of have applications for that. Because again, like with Vex, it's very expensive. It's more like a classroom tool, and you're not going to like build with Vex and keep it that way. That's one of the frustrating parts about Vex, is if kids make a really cool project, then I'm like, all right, now take it apart. It's just so sad. It's like you spent 5 months building a battleship with programmable turrets, and now take it apart. And with Bobots, I love it because it's good for my classroom for sure, but I don't know if they might be able to afford that. But I think that John and I have similar demographic schools where those kids are not going to be able to buy a $100 kit. But they could buy other smaller pieces if they were at a price point, in the $20.
Yeah, that's a great perspective of having the students be able to continue their learning and continue past the high school age.
Hey folks, Bly Hartley has a question over here. If you look at the Q&A pane.
I can read it. It says, we have more problems getting our high school administration interested in making time to learn tech and not just use it. In other words, Word and Excel. Thoughts on that? I don't know where Bly lives, but she volunteers as a robotics instructor at a high school and has done some pretty neat projects with her students. So probably through the volunteer channel, she's making things happen. But how could she get the administration to be more proactive and supportive?
There's some studies out that, kids who concentrate in CTE classes just do better across the board. Now, as a scientist, I think to myself, well, like, how do you control for, who takes classes? But they say, like, for all things accounted for, like, if you do hands-on learning, you're gonna, up your outcomes in life. And so for us, it's just like this, CTE is hot right now. The like administrators, they can talk about all the new pathways that that we're bringing in, and kids love it, and so I think it's good for everybody.
It would help to know where Bly lives too, like what the
Yeah.
community is.
Yeah, and I got to say the CTA buzz is big at our school too. We're trying to put some things in action right now. Also, I know that's huge, which I would love to be part of that. I'd also say like what Faith has hooked up with, and I've done in the past when I was in elementary school. If you have some local agencies that can help, because I know administrators freak out on budget. That's always the first thing. But if you can hook up with someone like SMUD is powerful out here on the West Coast. I don't know how far they reach out, but they're amazing, and Faith can probably speak to that too. The people at Solar Schoolhouse that work with them and do all these amazing things, and you can get amazing equipment for pretty much free, and they'll do trainings. I think a couple of years ago I went to Walker Ranch down in Marin County, and they did a whole week of trainings where we camped out and did solar pretty much all day long. So if you can get some support from the community too and show your administrators that it's not going to cost them another line item or whatever, that could be very helpful.
Yeah, and Bly, we're rural Georgia. Yeah, I figured, okay. And Bly, we're happy to send you some robots if you find a teacher there who's also interested in what you're doing. We'll help get you started.
Yeah, I'd say try to find a grant.
A grant?
Because if you say, hey, they're not going to say no to $5,000, right?
Right.
So, or doing a GoFundMe, or to get some stuff. So.
Yeah, in rural Georgia too, like if it's a farming community, maybe something place-based too might be of more interest to them. If everybody's going into ag or manufacturing in the community, how can you connect that to their education? Same thing you're talking about, find the industry.
Carol has a suggestion.
Carol.
Carol Haslett.
Yep.
Let's see. Can you click her hand, Ken?
Oh, okay, yeah, I'll let Carol talk. Oh, there you are, Carol, hi.
Oh, gotta turn the mic on.
She's unmuted. Oh, now she's unmuted. I think we're all ping-ponging her. And Carol, are you there? Okay, while we figure out what's up with her audio, I really want to thank you for just for teaching and giving these students the experiences, because I grew up with tools, and this was a big deal in our house. We made things, and we were just 24/7 hobbyists and didn't even make it to school a lot of time because of it. And through middle school and high school, the classes we remember the most were the computer class and then the workshop. And that's really what we do professionally too. So you do have an impact. It's very sometimes difficult to measure, but your students will be able to do their own plumbing. Okay, and this is $180 an hour in some places.
All right.
Yeah. Yeah, I do more of my own plumbing now, actually, after teaching these kind of classes.
Yeah.
I just changed my phone battery last night. So it was a little stressful, but.
So some questions from.
Am I here now?
Yes, you are.
Yeah, hi, Carol.
Hi. One suggestion I have, because it's based on my own personal experience, is if you have any local robotics clubs or such as that around, invite somebody to bring in the robots to actually show what they're doing with them to the teachers. On October 23rd, I'm going out to a charter school, an all-black charter school here in Seattle, and actually giving a demonstration of different kinds of robot kits and how they work and how they're programmed to the charter school staff and some of the students, so they can access what they want to have in their school. So being familiar with many, many kinds of different robotics and what they cost and stuff like that, I can do that. And of course, I'm going to be pushing the Bobot, but and the Scribbler. But that's one way to do it. Get in contact with one of your local robotics clubs. And I know there's a lot of them in Oregon. And they will come out to, they'll have members who'll come out to the school and show your staff and your finance people exactly what it is they have to offer and what's out there. And it gives them a hands-on feel thing instead of just an esoteric speech of what there is, because often they just can't visualize what you're talking about.
Cool. And I have more to add to that too. It looks like Bly saying yes, they say no, we have 30 activity bots already. So is the issue more that you have activity bots, but it's making time for the students to use it when they think the students should be working more in like the office technology platforms? Because if that's the case, I'm thinking of the webinar that we had earlier in the week where the teacher was talking about combining the robotics with the English and, you know, doing the sort of the cross-curriculum type stuff. I know that with Excel, doing data logging is something you can do with a robot and sensors and then export that data into Excel and then process it. And that may be a way to connect the hardware of the activity bots to these other platforms that they feel, these other office tools, computer software tools that they think it's important for students to show. So just maybe making a bridge between those two things with some of those ideas.
Data on an EEPROM on the Propeller activity board, or you could use the SD card slot and you can write data there and then bring it into a computer and analyze it. Find ways to combine things.
The Scribbler is a wonderful way to learn and teach math in a real hands-on thing. What does this formula do for me?
Yeah.
Great suggestion, Carol. Yeah, find the local robot club. It's true. Those people have been working with this for 20 years sometimes, and they really know the hardware and the cheapest way to do things, etc.
Good.
Any other questions out there? And by the way, Carol, she teaches too. She teaches robots in the Seattle Robotics Society Robot Club. And she's a retired engineer from Pac-Bell, I think.
Yep.
Phone company. Yeah, okay. And Carol will be with us on Tuesday for our hobbyist webinar, and she's going to show off some spooky stuff. And then I'll show off some downright sick stuff.
Mine is cutesy, yours is creepy.
Yeah, that's right. Okay, well, I want to thank again Kate, Stephanie, John, Scott, and Faith for joining us. This was tremendously useful for us as well. And we look forward to talking to all of you more this year and helping you out and sending you new hardware that we have. And we'll be sending you a small Parallax gift for participating today, as a matter of fact. It's the badge WX, so you can wear your geek badge now around your neck and it will display your name.
Cool. Thank you for having us. Appreciate it.
Likewise.
Yeah, thank you.
Okay, have a nice evening.
All right. Thanks, everybody.
All right,
That was
thank
great.
you.